Hello students, this is our third part of the lecture based on chemical equation and chemical reactions. So we will start from page number 39. The first point or first topic on the page number 39 is catalytic reaction. This is another type of reactions which is called as catalytic reactions. In these reactions, the reactions take place in presence of catalyst. So catalytic reactions can be defined as reactions which take place under the influence of a catalyst are called as catalytic reaction. Then another question arises, what is a catalyst? So catalyst is a substance which do not take part in the chemical reaction. It do not take part in the chemical reaction but changes the speed of the chemical reaction. So such substance which do not take part in the chemical reaction and changes the rate of the reaction is called as catalyst. Next is negative catalyst or inhibitor. A substance which decreases the rate of the reaction, means it slows down the reaction, is called as negative catalyst or inhibitor. And another substance is promoter. Promoter is a substance which increases the efficiency of the catalyst, means promoter is added to help the catalyst and it increases the efficiency of the catalyst. In the next slide we will see the examples. So the first example is of first they have shown us a general reaction. In the general reaction you can see that reactants are there and there is an arrow, and on the other side of the arrow you can see products. But on the arrow catalysts are written because catalysts are not written on the reactant side because they do not take part in the chemical reaction. They are just there to help the reaction take place. There is a first example of catalytic reaction for positive catalyst, KClO3, potassium chlorate. When potassium chlorate is slightly heated, or MnO2 and MnO2 which acts as a catalyst is added into it, manganese dioxide, MnO2 is manganese dioxide, it produces KCl and oxygen. This method is the laboratory preparation method for oxygen. So in this reaction MnO2 acts as a catalyst. It do not take part in the chemical reaction. It is neither a reactant nor a product, but it helps the reaction to take place quickly. Another reaction is this reaction is for negative catalyst, H2O2. It is hydrogen peroxide. Hydrogen peroxide, normally it decomposes very quickly to get converted into water and oxygen, but if alcohol or phosphoric acid is added into it, its rate of decomposition slightly decreases and slowly oxygen is produced. So therefore it acts as an inhibitor or negative catalyst. Alcohol or phosphoric acid acts as a inhibitor or negative catalyst in this reaction. In the next example is for promoter. In this reaction nitrogen and hydrogen treated to produce NH3, which is ammonia. In this reaction iron acts as a catalyst, and molybdenum, it is another kind of metal, it acts as a promoter which increases the intensity of iron, or which helps the iron as a catalyst. On the page number 39 lower side you can see next type of reaction, which is reversible reaction. Up till now we have studied that chemical reactions are mostly irreversible, but some of the chemical reactions are reversible in nature. So we can define reversible reactions as the reaction which occur in forward as well as backward direction are called as a reversible reaction. Let's take an example, and with the help of example we'll study what is reversible reaction. In the first example, nitrogen is reacted with hydrogen to produce ammonia. In this reaction nitrogen is treated with hydrogen and ammonia is formed, but this ammonia which is formed quickly breaks down, means some amount of ammonia quickly break down and again get converted into nitrogen and hydrogen. Therefore this reaction has arrows directing on both sides. You can see that one arrow is directing from nitrogen and hydrogen towards ammonia, and one arrow is directing back from ammonia to the nitrogen and hydrogen. Such reactions are called as reversible reaction. Now we will turn to page number 40. On the page number 40, on the upper side, you can see a reaction called as thermal dissociation reaction. Thermal dissociation reaction is very similar to that of decomposition reaction. This is decomposition reaction, but if decomposition reaction is reversible in nature, then such reaction is called as thermal dissociation reaction, and the word thermal is attached with it to indicate that this reaction takes place in presence of heat only. You can see the example of it. Ammonium chloride. Ammonium chloride, when heated, it produces ammonia and HCl, means decomposition is taking place. But if it is cooled, it again gets converted back into ammonium chloride. Now we will turn to the next way of classification of reactions, which is chemical reaction. Again are classified into three types. These three types are oxidation, reduction reaction, and redox reaction. In the table you can see that definition of I am defining oxidation reaction. Oxidation reaction is a reaction in which gain of oxygen or loss of hydrogen takes place. Reduction, I can define reduction reaction as a reaction in which gain of hydrogen or loss of oxygen takes place. And redox reaction can be defined as a reaction in which reduction as well as oxidation both take place simultaneously. Now let's see on page number 40 in the textbook. They have given us definitions of oxidation, reduction, and along with that they have given definitions of oxidizing agents and reducing agents. So oxidizing agents are the substances which cause oxidation, means the substances which provide oxygen to another substance and cause oxidation of that substance are called as oxidizing agents. Reducing agents are the substances which cause the reduction, means which provide hydrogen to another substance and cause its reduction. So such substances are called as reducing agents. We will see an example of oxidation and reduction. In the example you will see that copper oxide is treated with hydrogen to produce copper and water. So in this reaction, copper oxide is present in the reactant side and it is getting converted into copper on the product side. It means copper oxide is losing oxygen, therefore here reduction of copper oxide is taking place, and this reduction is caused by hydrogen, as hydrogen is removing the oxygen from it. And if we see the hydrogen is getting converted into H2O, means gain of oxygen is taking place, therefore hydrogen itself is getting oxidized.